Today we're gonna do systems of equations, linear and quadratic application problems. So when we are doing systems of equations, we are always trying to find where the two systems intersect. And that's the same for application problems. We're going to try to find where the line and the parabola or the two parabolas intersect each other. So for this example, it says Marina is a set designer. She plans movie sets using freehand sketches in her computer. In one scene, a banner will hang across a parabolic archway. To make it look interesting, she's decided to put the banner on an angle. She sets the banner along a line defined by the equation y equals 24.24x plus 7.2, where x represents the horizontal distance and y represents the vertical distance in meters. The archway is represented by this quadratic equation. Can Marina use the equations to determine the points where the banner needs to be attached? So I'm going to draw a little picture to kind of help me. So here's the parabolic archway, and she wants to hang the banner on an angle, and it's going to attach to points there, and then the banner's going to hang down. So I want to find where the banner is going to intersect the archway. So what I'm going to do is I'm going to take my banner equation and my parabolic archway equation, and I want to find out where they're going to intersect. So I'm going to use substitution, and what I'm going to do is y is equal to this, so I'm going to substitute in for y. So when I do that, I will get a new equation that'll be 0.48x squared plus 48x equals 0.24x plus 7.2. Now, when I'm solving a quadratic equation, I want my quadratic equation to be equal to 0. So I'm going to move these over to the other side. Sorry, I left a decimal behind. Now, I need to solve this quadratic equation, and factoring is not going to be easy. So I'm going to use quadratic formula. So I'm going to do opposite of b. That should be 5, 6, sorry. Plus or minus the square root of b squared minus 4ac all over 2a. And just like when we did quadratic applications, I'm going to go all the way down to the x. I'm not going to leave it in reduced radical form. So I'm going to get negative 4.56 plus or minus the square root of 6.9696 all over negative 0.96. So when I put that in my calculator, I will get x equals 2 and x equals 7.5. So just like when we've been doing systems by hand and for non-word problems, I want to find the y's. So I'm going to have 2 comma something and 7.5 comma something. So typically I would recommend plugging this back into the linear equation. So this guy, oops. And so when I do that, I'll get 2, 7.68 and 7.5 comma 9 roughly. Now, that was quite a bit of work. And this is going to be on the calculator part of your assessment. So another way I could solve this is I could take these two equations, this y equals 0.24x plus 7.2, and this y equals negative 0.48x squared plus 4.8x, and put those in my graphing calculator, just like we did with quadratics. And in my calculator, it'll look something like this. It'll be a line intersecting a parabola, and I can find those 2 points of intersection. So whether you do number 2 by hand or whether you do number 2 in your graphing calculator, I would like you to try number 2. And when you are done, play the video and check your answer. So just like the last problem, I'm going to set these two equations equal to each other because I'm trying to find where the two equations intersect. So if I solve by hand, your work should look something like this, and you will get two solutions. You will get x equals negative 8.54 and 58.54. Now in this case, x or t stands for time, and it's not possible to have negative time, so that negative answer is not going to work. But it is possible to have 58.54 seconds. And then when I plug 58.54 seconds back into one of my two original equations, I'll get 685.4. Now, again, you could have also done this by substituting both equations in your graphing calculator and finding where they intersect. And this is also a possibility, and you should get the same answer. All right, please pause the video now. Try example 3. When you are done, play the video and check your answer. So for number 3, we're going to use a similar approach that we did in 1 and 2. I'm going to set my two equations equal to each other and then solve. In this case, this one's factorable. So I factored out GCF, and then I factored. I found my x values. I substituted those x values back into one of my equations, and I got my y values. In this case, both of these work because in the problem it talks about determine the coordinates. So that would imply that we could have negative numbers and positive numbers. Now our last problem, number 4, is a little bit different. So let's read it. It says, Corey, Josh, and Dan went shopping for Halloween treats. Corey bought 3 chocolate pumpkins, 4 masks, and 8 candy witches. He spent $36.65. Josh bought 5 chocolate pumpkins, 3 masks, and 10 candy witches, and he spent $37.50. Dan bought 4 chocolate pumpkins, 5 masks, and 6 candied witches for $43.45. Now, I want to write a system of equations to represent this problem and algebraically calculate the unit price of each item purchased. So my goal is to find how much each item purchased costs. So I want to find out how much each chocolate pumpkin costs, how much each mask costs, and how much each candy witch costs. So what I'm going to do is I'm going to set up a 3-variable system. So for Corey's equation, I'm going to have 3x plus 4y plus 8z equals 3665. For Josh's equation, I'm going to have 5x plus 3y plus 10z equals $37.50. For Dan's equation, I'm going to have 4x plus 5y plus 6z equals $43.45. Now, it does say calculate this algebraically, but this is on the calculator part of your test. So you could also use matrices if you would like. But if I were calculating this algebraically, the first thing I would do is think about which variable I should eliminate first. So when I look at all of these, well, my smallest numbers lie within x or y. So I'm going to eliminate one of those first. So maybe I'm going to eliminate x. So if I'm going to eliminate x, I'm going to multiply the first two equations by each by a number so that way I can eliminate x. So I'm going to multiply my first equation by 5 and my second equation by -3. So that'll give me 15x plus 20y plus 40z equals 150. Not 150. It's going to equal 183.25. Then I'm going to multiply my second equation by -3. And that will give me this equation. Now when I go to add these two equations together, my x's will eliminate, and I'll be left with 11y plus 10z equals 70.75. So now I'm going to do the same thing, but I want to now incorporate my last equation. So if I want to eliminate x in my second two equations, I'm going to multiply my first equation by 4 and my second equation by -5. So when I do that, I'm going to get 20x plus 12y plus 40z equals 150. And when I multiply the second equation by -5, I'm going to get -20x minus 25y minus 30z equals -217.25. And I'm going to add those two equations together. My x's will eliminate, and I'll get -13y plus 10z equals 67.25. -67.25. So now I need to take those two equations and I'm going to stack them and solve, and I'm lucky actually because I have 10z in both. So I'm going to take those two equations. I'm going to have 11y plus 10z equals 70.75. I'm going to have -13y plus 10z equals -67.25. And I'm going to subtract those two equations. And what that'll get me is it'll get me 24y equals 138, which means y will equal 5.75. Now I'm going to take that y and I'm going to substitute it back into one of these two equations, and that will get me z. So z will be 0.75, and then I will take both of those and plug them back into one of my original equations. And when I do that, I'll get that x is 2.55. So then, keeping in mind I'm talking about the cost of each of these, I'm going to add dollar signs. So that means my chocolate pumpkins cost $2.55, my masks cost $5.75, and my candy witches cost 75 cents. Now again, you could also have chosen to done this with matrices because this is going to be on the calculator part of your assessment. So that is also an option.